I'm back once again, guys. So this is section 2.1 on page 290. So as always, I'm going to be sharing my screen and here we go. So simplify the radical expressions with numerical or variable radicants. So to get started, so the root of 121. So we're doing this. Oops, sorry. So this one, that's pretty easy. That's going to be 11, right? Because 11 squared is 121. Well, the cube root of negative 64 here, what would that be? Well, what's that number you multiply by itself? 3 times would be negative 64. Well, has to be negative, that's for sure. And the cube root of 64 is 4. Therefore, this one is negative 4. Negative 4 times itself, 3 times is negative 64. What is the root of 4th root of 81? I think that is going to be a 3. So to check it quickly, 3 times itself, 4 times, 3, 9, 27, 81 checks out. Okay, next. This is still page 90, so we are given radical expressions. And this is part of the construct your understanding. You are supposed to complete the table given below. So if x is 2, so I'm doing the first column. If x is 2, x squared is 4. All right. Um, if x is 2, square root of x squared, so must tells you to square it first, 4, and then you're going to get the square root 2. What about x cubed? So that would be 2 cubed is 8. What about the cube root of x cubed? So the cube root of 8 is 2. All right. X to the fourth, the cube root of, the fourth root of, no, the fourth exponent, or the fourth power of 2 is 16. And the fourth root of 16 is 2. What about x to the fifth, 32. And this is 2. All right, let's go to the second column. Negative 2 squared would be positive 4, right? Because you're multiplying negative 2 by itself. Now, this if x is negative 2, so look at it this way. X squared. So what you're going to do is you're going to square negative 2. And that's going to be 4, and it's 2 again. Okay. However, x cubed is negative 2 cubed, which is negative 2 multiplied by itself 3 times is negative 8. Yeah? And the cube root of negative 8 is negative 2. All right, we're clear about that. To the fourth exponent, fourth power, it makes it positive. Now, guys, take a look. When you get the fourth root of this one, it's still positive 2 again. All right? While negative 2 to the fifth power, negative 32. And the fifth root of that is negative 2. I hope you see the pattern, okay? So we are going to be comparing and ordering radicals. Check understanding number 1. Arrange from greatest to least. All right, so this is what you're supposed to do. As you can see in the first example, here, you have radicals that have different radicands. Of course, some of you would be probably thinking, okay, let me just grab my calculator. You can do that, but as I always told you, um, I wanted to do that to check your answer. And besides, in the test, you will have to show the math as to how you can actually do this properly without the use of a calculator. All right. But the trick here is this, guys. If you think about it, square root of 9, square root of 16, square root of 25. All right. Are arranged in order because square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. Now, guys, do you think it makes sense to say that whatever is the number inside this, all right, the radical, provided that the indices are the same, you can very well tell which one is bigger, all right? So in this case, root of 9, root of 16, root of 25, you know that the root of 9 is smallest, root of 25 is biggest because all of them have the same roots, all right? Now, Compare that to if you have different indices. For example, um, square root of 3, and then cube root of 5, and then fourth root of 9. All right, that would be pretty hard. There is a way to do that, but that is not something we are going to do today. All right, so let's just focus on the question right now. Let's see how we do it. So the trick here, guys, is just like what I gave you as a beginning example. Let's see if we can put them all um, as a, or turn all of them into an entire radical. So 5 root of 2, oops, 5 root of 2 becomes what? So the 5 goes inside, becomes 5 squared times 2. It becomes root of 50. All right. Now, 2 root of 5 becomes what? 2 goes inside times 5 equals, so that's times equals root of 20. On the last one, 4 root of 3 becomes 4 squared times 3. It becomes root of 16 times 3, 48. So which one is smallest? Root of 20. And then this is um, smallest, then next, and then next. All right. So the answer would be, to go back to the original question. Remember, guys, it's from greatest to least. Well, I don't know why it's like that. So you go back to the original expression. The final answer is 5 root of 2, and then 4 root of 3, and then 2 root of 5. All right. There is your answer. Next, this one. So as you can see, all of them have the same index 3. This one, this one, this one. All right. So what you're going to do here is 9 cube root of 2, 11 cube root of 2. So um, you might think that, oh, wait a minute. Do we need to turn them all into entire radicals? Well, you can do that. But then, guys, take a look. Um, do you notice that all of them already have a cube root of 2 as your radical? So I don't think we need to turn this into an entire radical anymore, because the number in front pretty much tells you which one would be the biggest, right? Therefore, I think the biggest here is this one. So the first one is 11 cube root of 2. It's the biggest. The next one is 9 cube root of 2. Last one is 8 cube root of 2. Now for this one, all right, just use the calculator, because they have different indices. There is a way to do that, but that is not covered by this course. So let's, in the future, maybe I will just show you real quick how to do that. There's a way. All right. So if you were to use the calculator, you will see that this one would be about 5.04 for root of 2. Oops. Would be about 5.65. Well, 3 cube root of 5 would be about 5.12. So you can tell which one is biggest. The middle one is biggest. All right. So the answer would be 4 root of 2, and then 3 cube root of 5, and 5, and 3 root of, or 3/4 root of 8. All right. Now, I'll stop there for a while, and then you do the practice. Bye now.